Okay, and that brings us to exercise 8.6, where we are given a file of last names, and it's in a CSV file. So I guess it contains the name and the number of people who are named that. I guess, let me just check. I actually saw that file before, yeah. So I think Jensen is the most frequent one, then you have Nielsen, Hansen, and so on and so forth. Let's see who we have at the bottom. Yeah, so we have a couple of rare ones here at the bottom. Okay, and what do we need to do with that file? We need to compute the fraction of people who have a certain name. So that is this name occurrence function that we want to implement. So I just copy paste this example, and it should give a roughly 3%. So let's pay attention to that number, and then we'll try to solve it. So we have one here called name occurrences. This is kind of a fun problem, I feel. So let's call it return fraction. Right? Fraction is the number of relative number of occurrences. Maybe it should be equal percent, because we need to return that as percentage. Sorry. And I guess that's it. So we'll start this in a debugger. And then the first thing we need to do is we need to load this CSV file. So how do we do that? I actually I don't think I ever used this library in particular. So we have this library. Let's see if there's a load. Reader. Yeah, done. Not this reader, accept. Maybe just give it the path. I wonder how it works. Let's see if we can cheat a little and read about it. So we need to give it a file object like this, and then we loop over it. Nice. Okay. Nobody saw that. Sometimes when everything fails, it's a good idea to look at the documentation. So we open the file, and then we pass that to this reader function, and that gives us some kind of thing we can iterate over like this. It looks like a list. Let's print out each row just to see what we contain. Cool. So how do we approach this? I think the way I will approach this is to first create a dictionary with the names as key and the number of occurrences as the values. I think that seems like a reasonable way to start processing this data. So I create an empty dictionary. Wow, it's going a little bit slow. I guess there are a lot of different names. So now I have a row, so I take the first element of the row, and I say that should be a key in my dictionary, and the value should be the second element of the row, namely the number of occurrences. And I can see that the occurrences are actually strings, so I want to convert them to integers, and I can do that using the int function. And I don't think we should print it out, because that's obviously going very, very slowly. What we should probably do instead is we should probably tell it to stop the debugger, because it's just taking too much time. So I still have a breakpoint down here, so let's just start the debugger again, because that will also tell us if D is defined correctly. So I go to the debug console, and now we can see that we got 64,000 last names. Wow. So what I basically need to do now is compute the fraction of names that had fraction of occurrences of the given name. So I can just look up Andersen in my dictionary, and I can see that 161,379 has that last name, which is more than I would actually expect for some reason. Okay, So now we need to divide by the total number of known last names in Denmark, like basically the number of people this data set represents. So it's a dictionary, so if I do d.values, I get all the values, then I can just sum them together using the sum function. So this data set has data for about a little over 4.5 million. So now it should actually be easy. I get the number of Andersens and I divide it by that, and then I need to multiply by 100 to get the percentage. That gives 3%, which is what I would expect. And that's actually what I return here. So we quit it. And now let's run the file. 3.446%. Let's see if that agrees with what we expect. Yeah. Okay, so let me just do the tests. Where do we have the test? It's probably this one. It seems to work. I mean, one has to check, right? There's not a lot of people called Herlau. And actually, I think I know the number of people, so I mean, let's just find out. So, 4. Yeah, that seems correct. Okay, so you can experiment a little with this function yourself and see if you agree with the data set. Okay, so I think I'll end this video here.